And welcome to the review preview solutions for the week 6 homework. We're going to start with number 1, which says the function of f is defined by the equation f of x is equal to 1 plus the square root of x plus 5. Part A says to write an equation for the inverse of f of x. There's a couple of ways to do this. I think I'm going to go with the method we learned in 5.1.3 where we're going to switch x and y. So first I'm going to replace f of x with y. And then before we begin to solve, we're going to flip-flop x and y. So we have x equals 1 plus the square root of y plus 5. Okay, so then that next step is we're going to solve for y. So to do that, I'm going to first subtract 1 on both sides. So I have x minus 1 equals the square root of y plus 5. To get rid of the square root, I will square both sides. So I have x minus 1 squared equals y plus 5. And then my last step, I will subtract 5 on both sides. So I am left with x minus 1 squared minus 5 is equal to y. And then we'll rewrite it, so we're going to change that y to be the inverse of f of x. So that's where we do that f and kind of have that -1 notation there. And then x minus 1 squared minus 5. All right, so we found the inverse equation. Then the second question asks us to complete the table below. So it wants us to complete the table for the first f of x equation, the original right here, and then fill in the one for the inverse here. So you could do this a couple ways. You could take each of these points and plug it in for x and see what you get. I was feeling slightly lazy, so I went to Desmos and typed it in. So y equals 1 plus the square root of x plus 5. I clicked the gear to the table, and then I typed in the values I wanted, which were -5, -4, -1, 4, nope, and 11. So it looks like my values are 1, 2, 3, 4, 5. So I'm going to go ahead and write those in. And then to find the inverse, remember the trick is you just flip-flop the x and y values. So on this side, these will be 1, 2, 3, 4, 5, and -5, -4, -1, 4, and 11. Part C asks us to that it already has graphed the original function here and the line of symmetry, but it wants us to graph the inverse. So let's look at those points and plot them. So we have 1, -5. Then we have 2, -4. Then we have 3, -1. Then we have 4, 4. And 5, 11 is a little bit high up there, so I can't graph that one, so we'll stop there. And I'll go ahead and put my line through. And there we go. All right, so number 2 says that it wants us to rewrite this equation so that it begins with x equals. So I made a little side note to the side of where all these pieces go here when we're working with log. And just so you can like kind of start to see the pattern of how we move things around. So if we want to write this as x equals, I can see here that this 2 will become, we'll go right here, right? And then we've got this equal to y, and here that becomes the exponent, so I'm going to make that the exponent, equals 2x. Okay, so now number 3 wants us to do something similar that we did in the notes. It says every exponential equation has an equivalent logarithmic form and every logarithmic equation has an equivalent exponential form. So it gives you an example here, 4 to the third power equals 64, and then it shows you what that's equivalent to. So you can use this to kind of help see the pattern, where to move all the pieces, but you can also use this note here with just like the variables to help you, the letters to help you. So it wants you to complete this table. So I would say go ahead and just pause the video and see if you can fill these out just by looking at these patterns here. Okay, so really try to work through these on your own just a little bit so you can see the pattern. Just because on your quiz it'll be a little bit tricky if you haven't looked at it at all. But I'll go ahead and start filling in the answers so you can check it out. But really try to think about it while I'm doing this. And if you're still struggling to see the pattern, make sure you talk with your teacher. Okay, so let's go ahead and look at number 4. This one's a lot like what we did in the homework as well, so we can move everything around. So we've got log base 3, 243 equals what? So the way that we would set this up, if you look, 3 would become our base here, and then the question mark would become our square root. So this will say 3 to what power equals 243. And you can use guess and check a little bit for that, right? Like if I took 3 to the third power, well, that's not it. That's not it. Oh, 243. So I know that 3 to the fifth power is equal to 243. Here this says what number to the fourth power equals 16. So I mean, you can try things out, right? I mean, you could do 4 to the fourth power. Okay, well, that's way too big. What about 3 to the fourth power? That's too big. How about 2 to the fourth power? Oh, that's 16. So 2 to the fourth power is equal to 16. Here we have 5 to the 0 power is equal to what? So let's find out. And anything to the 0 power is 1. And then this one is a little bit tricky. This says 9 to what power is equal to 3? Okay, well, if I did 9 squared, well, that's too big. See, I gotta play around with it a little bit if I try in the negatives. Nope. But 9, let's try to the 1/2 power. Ooh, that's it. So 9 to the 1/2 power is equal to 3. Okay. And then for number 5, it says if 10 to the 3x power is equal to 10 to the x minus 8 power, solve for x. So because these both have that same base 10 here, 3x and x minus 8 are going to be equal to each other. So we're just going to set those equal to each other to solve for x. So 2x is equal to -8, divide by 2, so x is equal to -4. Okay, and that's all for this video. Thanks for watching.